And rolling in 5, 4, 3. Okay, kids. Today we're going to talk about sequences. Lesson 8-2. You want Michael Starr? Okay. Now, here's what we have. All kinds of good stuff.
He
Okay.
needs to start coming in with people rap songs.
All right. That's what's up. That's right over here. Okay, all right, so we have e to the x. Now, as x approaches infinity, the following functions either diverge or converge. Now, in the dictionary, diverge is to go in opposite directions. To converge is to come together. All right? That's kind of the basis of this thing. So, e to the x, that's our old familiar friend. E to the x. Remember that one? Takes off, doesn't it? Okay? As x approaches infinity, going down that way, what are the y coordinates approaching? You know what? They're just escalating. They're just going to infinity. Would you think that would be diverge or converge? You know what? That's called diverge. Because the y's... Hey, that's right. Go ahead. Hey, please. We welcome all participation. Steve. Yeah. All right. Steve Smith. Yeah. All right.
I
Okay.
don't have last name Smith.
Oh, that's right. You do. Yes. You are. That's right. Stephanie Jackson. Okay. All right. Now. All right. So as the x's go to infinity, the y's go forever. That means there's no boundary, is there? No boundary. That is called diverge, or you can say it diverges. Okay. All right. Now. What about e to the negative x? We know that one too. We've grabbed it so many times I can't believe it. That one is what? Coming in for landing. Switch around the y-axis. So, as the x's approach infinity, what do the y's approach? 0. They never get there, but they get infinitely close. Nice call. Yes, that's right. All right, so that you would call what?
Converge.
Converges, exactly. This graph converges towards 0. It's getting closer and closer to 0. Okay?
So our reference point is zero, like it diverges or converges from zero.
Well, not necessarily, because you could have a horizontal asymptote up here, and it would be converging to that line, in other words. So what you're looking for really is a horizontal asymptote, period. If you're going towards a boundary that you can't quite cross, but you're getting close to it,
Okay.
convergence basically means I've got a horizontal asymptote, so if you put that down, that'll always work. Diverge means there's no boundary at all, it just goes unbounded, right? And that can also be down. If you go down forever, that's also going to be divergent, right? Because you can't stop.
Will it ever ask us, like give us two equations and ask if the two graphs are converging or diverging?
No, it would only be one at a time. Okay? All right, so the next one's going to be y equals x to the 5th. Okay? Oh, by the way, a little side note here on this last one. If the question was asking x going to negative infinity, it would actually be what? It would actually be diverging going that way. So it depends on what direction you went. Okay? Just a little side note. All right, now x to the 5th. Ah, yes, our old friend.
Snake.
Okay, there it is. X to the 5th. There it is. So when you draw these snake, I go past this line, I'm out of the shot, right? Okay, all right. So x to the 5th. Whoop, there it goes. Is there any boundary? Can you stop this one? Oh no.
Good luck.
That's right. Yeah. Good luck. All right. As x approaches infinity, y approaches infinity as well. Therefore, this function does what? Diverges. Okay. Now, the next one is the 5th root of x. The 5th root of x is the what? Yeah, because it's the, what is it? Yeah. It's the inverse of that one, right? If it's the inverse, isn't it the same exact size snake, except it goes like that and like that? Okay, same size. So, for the next one, the 5th root of x goes like this. Okay, same picture. Turn around. All right. Now, as I look at the 5th root of x, you know what? Boy, that fifth root of x sure is leveling off there. Huh. It's really leveling, isn't it?
Right.
I wonder if I put a boundary up here like 100. What if it'll ever cross that?
No.
Yeah.
Certainly it can't, right? Wait a minute. You know what? You could pick a big enough number whose fifth root is higher than 100. Sure could, pick a really big number. What if I set the bar at 1,000,000? Boy, it's going to take a long time, but eventually it will surpass it. You know why? Because it does not have a what?
That's a zero.
It doesn't have a horizontal asymptote. There's no boundary. Very slow, but it will eventually cross it. Same with natural law. It levels off, but it will cross any boundary. Okay? If this, does the snake over here, does the snake have vertical asymptotes? No. So the sideways version doesn't have any horizontal asymptotes. Okay? So this one does diverge. I know it levels off, but it still does not converge. It diverges. As x approaches infinity, y will approach infinity. Yeah. Okay? Seems kind of strange when it's leveling out, but there's no boundaries. All right? So basically, if it has a horizontal asymptote, that's the only way that it can converge. Okay? Here's this one. Y equals 1 over x squared. Did this one in the last test, as a matter of fact. 1 over x. 1 over x is a hyperbola, like this. But guess what? If it is x squared, all the outcomes must be what? Positive. Therefore, located where?
West side.
Above. I'm not going to get gang signals here. It's not hyperbola. All right? So you go to that's bad. Okay. So that means they are both above the x-axis, therefore both positive. So it's going to be one of these and one of these, and it does have an asymptote on it. Okay? Matter of fact, it has a vertical asymptote as well. That doesn't really matter here, but it does have a horizontal asymptote. So as the x's approach infinity, the y's approach what? 0. Okay? So that means that this function converges. Exactly. Horizontal asymptote means converge. Okay, last one in this category, the sine of x. This is kind of a strange one. All right? The sine of x. Doesn't it just go up and down and up and down?
Yeah.
Back and forth, back and forth. Matter of fact, the name for that going back and forth like that.
Oscillating.
Oscillating. Hey, smart
Yeah.
class. All right? That is an oscillating graph. Okay? Yes, yes, Stephanie and Steve, plus 10 for all of you. Okay, now, this is a sine graph. Now, does it really take off? Go up forever? It never really takes off. But guess what? Does it converge? Does it ever come in for a landing and go towards a horizontal asymptote? It never does it? In math, anything that does not converge is automatically called divergent. Automatically. So if it's not converging, you have to put divergence. It's kind of a strange divergence, not quite the English dictionary definition of going into a different direction. But it's still not converging in math, so you have to say diverge. Or remember this, if it doesn't have a what, then it's divergent. It has to have a horizontal asymptote, otherwise put divergence. Okay?